We will study about the clipper and clamper circuit. You know, a clipper circuit, an electronic device that is used to remove the output of a circuit to go beyond the preset value, that is voltage level, without varying the remaining part of the input waveform, that is called the clipper. In clipper circuit, we will study about two clipper today, that is shunt positive clipper with positive shunt bias and shunt negative clipper with negative bias voltage. Okay, this is my circuit diagram as per the manual. Here the V in AC voltage is 16 volt peak to peak 1 kilohertz as per the instruction. Okay, and this is 1 kilo ohm resistor, and this is my diode, and this is your 5 volt DC source, and this is the circuit diagram for shunt positive clipper with positive shunt bias voltage. And this is practical circuit. Here you can see this is my diode, which anode is connected to the resistor 1 kilo ohm, and this terminal of the resistor is connected to the CRO. This is my CRO, sorry, this is a function generator is connected to the function generator in channel 1, where I put the amplitude here 16 volt peak to peak and frequency 1 kilohertz. Okay, now the frequency is 1 kilohertz, amplitude is 16 volt peak to peak, offset voltage 0 and phase is also 0. Sine wave I given here. This is come to the circuit resistor terminal, and another one to the negative part of the 5 volt supply DC source. You can see here this is my DC supply, where the common one I am connected to this terminal, and the positive I am connecting to cathode of the diode, and the CRO channel 1 I connected to the input voltage, whatever come from the function generator, that I connected to channel 1 of the CRO, and across the diode I connected to channel 2 of the CRO. This is my output waveform. You can see here this is my input signal, and this is my output signal after clip up or remove the positive part of the waveform. Here you can see I am supplying here 5 volt. This minus C is the C is pressed, and the supply voltage is here 5 volt. Okay, this is 5 volt and this is my output. You can measure now the voltage. If you want to measure, then you can see how much division it is. 1 2 3 3.2 division is here. 3.2 division into 5 volt per division gives you 16 volt peak to peak, that we supplied from the function generator. Okay, then this is my output wave in channel 2. Then we will measure this one also. Here you can see 0.2 4 6 and 8, 0.8 division into 5, this is 4 volt. 4 volt is clipped here at positive side for the positive clipper circuit. Then we will go for the negative shunt negative clipper with negative bias. Okay, before that we will do this graph of the in XY mode, V out versus V in. If we will make it in XY mode and trace the XY, this is our graph. You can see this is our graph, V out versus V in. This is my graph, you can see here. Okay, you see here. Then we will go for the shunt negative clipper with negative bias voltage. For this we will just change the diode direction, and we will supply the negative voltage instead of this positive voltage. Then we will see what happened here. Okay, now I am changing the direction of the diode. Also I am removing this positive 5 volt, and I I am supplying the negative 5 volt here. Okay. You can see both the channel 1 and channel 2. See this one. This is your input voltage as it is 16 volt, and this is our negative clipper circuit. It is also almost 4 volt. We are supplying 5 volt, but it is practically it is coming 4 volt. This is our negative clipper circuit, and if we will make the XY mode, the graph is like this. You can see this is my graph V out versus V in for negative shunt clipper with negative bias. Okay, now we will study about the voltage doubler circuit. Okay, you know that voltage doubler circuit is nothing but the two clamper circuit connected in series. Okay, clamper circuit, you know, an electronic circuit that is used to alter the positive peak or negative peak of the input signal to definite value by shifting the entire signal up and down. This is my voltage doubler circuit. Here I am using this voltage source, mention this here 6 volt peak to peak 1 kilohertz, and this is 10 microfarad capacitor, and this is a diode D1, this is diode D2, and this is also a 10 microfarad capacitor. And we will measure the voltage here at first diode D1, and we will get the voltage in diode D2 is double of voltage showing here. That we will confirm today by this experiment setup. Now you see, this is my practical experiment setup where I am using this diode as D1 and this diode as D2, and this cathode I am connecting to the capacitor positive terminal as per the circuit diagram, and the negative terminal I am connecting of this capacitor. I am supplying the voltage, AC voltage from the function generator, and this diode D2 anode is connected to the positive terminal of the capacitor, and the cathode is connected to positive terminal of the capacitor 2, and the negative terminal is connected to ground. Okay, now this is my CRO, which channel 1 I am connecting to measure the input signal. Here this is my channel 1, I am connecting here at diode 1, this point, diode 1 with respect to ground. This is my channel 1 connection to see the input here, and this is my output at channel 2 I am using to see the output at D2 voltage. Okay, we can see here my input signal is now this one. You see, I am supplying in function generator 6 volt. Let it be. Once again I will set it 6 volt. Now the voltage is 6 volt and the frequency is 1 kilohertz. Okay, and this is, you can see here one division. If I will ground both the channel and release it, you can see this is 1.2 division into 5 volt for division. It will give the input of 6 volt. You can see I am only connecting channel 1. Now it is in channel 1 6 volt. If I will go for the channel 2, this is my channel 2. After rectification, the output is coming at channel 2 is this one, full division 5. This is almost 6 volt of DC, that is your AC of 5 volt, which we will measure by using multimeter. We will verify the voltage doubler here. You can see I am connecting the positive terminal. This is my multimeter I am using as a voltmeter. In DC voltage I am measuring here now. Okay, the positive terminal I am connecting to the diode D1 and the negative I am connecting to the ground. My voltage is 2.5 volt DC. Okay, 2.5 volt. If I will measure the voltage at diode D2, you can see what is the voltage now. At multimeter you can see this is 5.12, just double of that one, that is 2.6, and this is 5.12. okay, this is my voltage. I am writing here the voltage at here is 2.6 volt and the voltage here is 5.12 volt, just double of this one. Before without connecting RL, now my RL is not connected. Okay, and this is my waveform. You can see here also, this is my waveform. You can see this is ground. Okay, this is shifted from this one, this is my origin one, and this is my the straight line is your DC output, this is your output, and this is your input waveform. Now we will connect the resistor across the capacitor at output side. Now I am using a 47 kilo ohm resistor. You can see the waveform will change. You can see to the CRO, this is my input and this is my output. You observe the output while connecting the resistor. I am connecting now. You can, it is shift. Okay, in this case we will measure the voltage, DC voltage at input and output side, and note it down. My voltage is now here 2.386 and output is 4.75, double of this one. Okay, this is 2.38, this is 4.75. now I am connecting, you can see this input here once again. I am connecting a 27 kilo ohm. You can observe here it is again changed, the output waveform is changed, reduced. Okay, now the input is 2.3 and the output is 4.63. this is also double, but the voltage level is reduced due to the resistance value. Without using resistance, the voltage is more than using a resistor. You can observe this thing. Now my voltage is 1.8 at input side or diode D1, across the diode D1, and across the diode D2 this is 2.8, 1.4, and this is 2.8. this is also double, and the waveform you can see in CRO, it is changing. Okay, this is 1 kilo ohm I am using now. If I will connect a less value of the resistor, this is 27 ohm, you can see the output waveform and input waveform are changed now. Okay, here also input voltage for DC is 0.22 and the output is also 0.26. it is 0.22. you can see this is 0.22 and this is 0.26. it is not double because the resistance value is very less, so the capacitor is now discharging rapidly, so it is not giving you the double voltage. Okay, for other more values of the resistor, it will give you the double of the voltage. Okay, you see now the observation by without using the resistor in voltage doubler circuit while giving this 6 volt, but we are getting at diode 1 2.5 volt and diode 2 is 5.12, which is double, and in 47 kilo ohm we are getting 2.38 at input and 4.75 at output. In 27 kilo ohm this is 2.3 volt in D1 diode input side and 4.6 is output side. In 1 kilo ohm 1.4 volt, and in D2 it is 2.8. All these values are double with than the input diode D1, but in 27 ohm this is not exactly double because now the diode the capacitor start discharging, so it is not double. Okay, you can see here when the capacitor there is no resistor, the capacitor is acting as a high resistance value and open circuit, so the for DC it is open circuit, so the value is more at input and output, while the resistance value will decrease, then the voltage is reduced. Thank you.